This video introduces Gaussian process. Gaussian process is a stochastic process. It's based on a multivariate Gaussian distribution. Gaussian process is used to predict the new value at the new variables x from the training observations through a kernel function. That means, for example, at each random variable, we have a Gaussian distribution. And then we have these observations. We use these training observations to find a new point. What's the Gaussian distribution here? That means we need to predict the mean and the variance of the Gaussian distribution at this point. To do so, we need to first see what's the multivariate Gaussian distribution. For example, we have many random variables, each variable corresponding to one Gaussian distribution. Multivariate Gaussian distribution, that means we combine these Gaussian distributions together to get a new Gaussian distribution with the mean calculated from these random variables and this covariance calculated from this expectation. That means we need to use from this multivariate Gaussian distribution. We need to form a Gaussian process, use this Gaussian process to predict the new value function f at the variable x. This mean is of the Gaussian process, and this covariance is a Gaussian process also. So usually we set up this mean equals 0. That means we define a kernel function and to form a Gaussian process. Based on the Gaussian process, we predict the function at x. If we set the mean of a Gaussian process equals 0, that means we can use a covariance function k, that means kernel function, to evaluate the correlation between the observations. A lot of the kernel functions are available, but the most popular one is the reduced basis function. Here is this Gaussian. And you see, if x equal to x prime, this means this kernel function is a maximum. That means Gaussian function corresponding to x is the same as or maximum correlation with this Gaussian distribution corresponding to x prime. If this value is a large, difference is large, that means it's a kernel with the value is small. That means this Gaussian distribution has a large difference from this Gaussian distribution corresponding to this x prime. Here L is a length parameter. So then now we can use this Gaussian kernel. We use this kernel to define the covariance matrix. Here is a diagonal items. Diagonal entries. Here is the variance of the Gaussian distribution corresponding to this x1, and then the x2 to xa. The off diagonals are the correlation between the observations. So from the training observation, we got this covariance matrix, and then we define this k star from the kernel, from this between these new variables with the x1, x2, xa, and also we define the key double star as the variance of Gaussian distribution correspond to this new random variable. And then now we get the Gaussian process here. That means we combine as a training observations and the new value together, and we get this Gaussian process. We then we form that means we can form this Gaussian process to predict this new value. This means we have this training observations. This is a new value. We put them together to get this left side. And then let's see what's the idea behind this Gaussian process. Suppose we have a sample D from a multivariate Gaussian distribution. Here the mean is equal to 0, as we mentioned. D is the covariance of the Gaussian process. And then now we can split this D into two subvectors, y and y star. And then we can, if we define k double star, k star under D, then we get this Gaussian process matrix. However, if D and y star are Gaussian, and then we can solve this Gaussian process through the regression method. We can find the conditional probability of this y star condition on this training observations y. So we have a mean and covariance of the Gaussian process. From this conditional probability, we can estimate the mean of the Gaussian distribution from this mean equal this the mean of the Gaussian process, and the variance of the Gaussian distribution is equal to the covariance of a Gaussian process here. That means from this Gaussian process, we get this probability, and from this probability we can estimate the mean at this point and the covariance at this point, variance of this point. That means we can predict the Gaussian distribution corresponding to this point. For more details, please check with this reference. Thank you. Bye.